Hi, this is a question that appeared on JEE Advanced 2018, paper 2, and this is a multiple choice question. It has got more than one correct answer. So the question is basically from conic sections. This is a good question. So you have a circle here and a parabola and ellipse. So this question is a good blend of concepts. So the construction of the question is really good. So let us go ahead and solve this question. But before we do that, I would strongly recommend all of you to pause the video at this moment and give this question a try. So let us go ahead and solve the question. So consider two straight lines, each of which is tangent to a circle. So here we are given a circle x square plus y square is equals to half. So the radius of the circle is 1 by root 2 and center is 0, 0 and a parabola y square is equal to 4x. If you compare it with the general form, y square is equal to 4ax, a will be 1 here, and the focus is 1, 0. So let us draw these two curves on coordinate axis. So this is y-axis, and let's say here we have x-axis, and this is the circle. So since the radius is 1 by root 2, this point will be 1 by root 2, 0, and now we have a parabola like this. So this parabola is y square is equal to 4x. So the focus of the parabola lies somewhere here, 1, 0. Now it is given in the question that there are two straight lines which are tangent to both circle and parabola. So let us draw those straight lines. So, okay, fine. This is one straight line that is let us say it touches the parabola at this point and circle at this point. Let us draw one more straight line. Let us say this touches the parabola somewhere here, and both of these straight lines intersect at a point Q. It is given in the question. So now at this point, before going through the next part of the question, so let us analyze things about this construction first. So the circle is symmetric about x-axis. The circle looks exactly same above and below the x-axis, and the parabola is also symmetric about x-axis. The parabola looks exactly same above and below x-axis. So these two tangents, the blue lines, will intersect at a point on x-axis because of the symmetry along x-axis. So let this point be h, 0. Let us find out the value of h. So the equation of tangent to a circle is y is equal to mx plus r minus m into plus or minus r into root of 1 plus m square. So let this tangent be L1 and let this tangent be L2. So the equation of L1, let us say, this is a tangent to circle, so we can write this equation. So y is equals to mx plus r minus 1 by root 2, since r is 1 by root 2, into 1 plus m square. L1 is also tangent to parabola. So the equation of tangent to parabola is y is equal to mx plus a by m. So a is 1 here. So this is 1 by m. So since this is the equation of L1 and this is also the equation of L1, so these two equations should be same. So 1 by m should be is equals to plus or minus root 2 into root of 1 plus m square. So this implies square it on both sides. 1 by m square is equals to 1 by 2 to 1 plus m square. So 2 is equals to m power 4 plus m square. M power 4 plus m square minus 2 is equals to 0. So m power 4 plus 2m square minus m square minus 2 is equals to 0. M square into m square plus 2 minus 1 into m square plus 2 is equal to 0. M square plus 2 cannot be 0. So m square minus 1 equals to 0. M is equals to plus r minus 1. So we found that the slope is 1. So the slope of L1 is 1 and the slope of L2 is minus 1. So now let us find the equation of L1. L1 is, from this we can write y is equal to, slope is 1, so x plus 1 by 1. So y is equal to x plus 1. So now to find out point Q, we have to put y is equal to 0. So y is equal to 0 implies x is equals to minus 1. So point Q is minus 1 comma 0. Done. So this point is minus 1 comma 0. Now let us go ahead and read the rest of the question. Consider the ellipse whose center is at origin and whose semi-major axis is OQ. So here we have O. Now, so we are done with the tangent part of the question. So let us erase the tangents we have drawn. All right. This is y square. Here we have point Q. So now what is given in the question? We have an ellipse, the center is O, whose semi-major axis is OQ. So this is the semi-major axis. So the length of semi-major axis is 1. So it also passes through 1 comma 0. And the length of minor axis is root 2. Minor axis is root 2. So semi-minor axis is 1 by root 2. So it passes through this point, since the radius of this circle is also 1 by root 2. So there is an ellipse like this. So this is the ellipse that we have. Then which of the following statements are true? So length of minor axis is root 2. So 2b is equals to root 2. So b is equals to 1 upon root 2. And length of semi-minor axis OQ is equals to a is equals to 1. Now let us find out the eccentricity of this ellipse. E square is equals to 1 minus b square upon a square. So 1 minus 1 by 2 by 1. So that is 1 by 2. So E is equals to 1 by root 2. Eccentricity of the ellipse is 1 by root 2. Now we have to find out the latus rectum, the length of latus rectum. So we know that length of latus rectum is 2b square upon a. So 2 into b square is 1 by 2 by a is 1. So this is 1. The length of latus rectum is 1. So option A is false. Option A is true. Eccentricity is 1 by root 2. Option B is false. Now let us go ahead. The area of the region bound by the ellipse between the lines x is equal to 1 by root 2 and x is equal to 1. So let us draw the lines. X is equal to 1 by root 2. So x is equal to 1 by root 2 is this line, because the radius is 1 by root 2. And x is equal to 1. X is equal to 1 is this line. Correct? So now we have to find out this area. Okay. How do we find out that area? Okay. Okay, let us color the areas. So this is one area. Sorry, this is all not needed. So we have to find out that area. So let us write the expression for that area. So this area will be integral x goes from 1 by root 2 to 1 y dx. So this will give the top portion. So if we do twice of that, so that will give the total area. So now let us go ahead and solve this. So area is equals to integral 1 by root 2 to 1 y dx, twice of this. What is y? So x square by a square plus y square by b square is equal to 1. This is the equation of the ellipse. A is 1, so x square by 1 plus y square by, what is the value of b? B is 1 by root 2. So b square is 1 by 2, that is equals to 1. So x square plus 2y square is equals to 1. So y square is equal to 1 minus x square by 2. Y is equals to 1 by root 2 into root of 1 minus x square. So a is equals to 2 times 1 by root 2 to 1. So y is 1 by root 2 root 1 minus x square dx. This is the area. So bring out 1 by root 2. So this will be root 2. So 1 by root 2 to 1 under root 1 minus x square dx. Now put x is equals to cos theta. Then the lower limit will be pi by 4, 45, and the upper limit will be 0. Correct? So x is equal to 1 by root 2, then theta is pi by 4, x is equal to 1, theta is 0. So now dx is minus sine theta d theta. So this is root 2 times integral pi by 4 to 0 root of 1 minus cos square theta into dx is minus sine theta d theta. So root 2. So let us change the limits 0 to pi by 4. So we have this minus sign. So if we change the limits, we can get rid of this minus sign. Root of 1 minus cos square theta is sine theta. And here we have one more sine theta. So sine square theta d theta. So that is root 2 0 to pi by 4. Sine square theta is 1 minus cos 2 theta by 2 d theta. Bring the 2 outside. So it will be 1 by root 2 integral 0 to pi by 4 1 minus cos 2 theta d theta. Now integrate 1 by root 2. So integral of 1 is theta minus integral of cos 2 theta is sine 2 theta by 2. This goes from 0 to pi by 4. Put the values. 1 by root 2 into theta is pi by 4 minus sine 2 theta 2 pi by 4, that is pi by 2. Sine pi by 2 is 1 minus, if we put 0, this will be 0 and this will also be 0. So this is the area, required area. So So let us go through the options. It is given in terms of pi minus 2. So let us simplify this further. So 1 by root 2. So LCM 4. So pi minus 2. So 1 by 4 root 2 into pi minus 2. So that is option C. So option C is correct. Option D is incorrect. So the answer is A and C.